So the runtimes are different whenever you are creating cluster for different kind of things. You can see those all here, but community edition doesn't listed all. Whenever you are into the license edition, there might be three types of course, one is deprecated in a latest version. So let me explain you what those are. So the first thing is what it is, data science related. I mean to say data engineering related cluster. Okay, that is called normal. I mean regular cluster or something else. Right. Whenever you are going to create a specific runtime for machine learning, okay, that is called something called ML flow. Right. The cluster type is ML flow. Right. So if you are going to create specific clusters for what I can say, uh, biochemicals and research methodology. Of course, it might be any kind of these things. So at the time, the cluster type is genomics. Okay, it's a we can simply say it biomedical. It might be for anything. It might be for research. It might be for DNA research or RNA research or analyzing the human body or any in nucleus. Anything doesn't matter, right? If you are going to do for biochemical or medical research, it's a uh, genomics. Okay, this genomics is deprecated from Databricks because instead of creating this type of different kind of uh, cluster groups, Databricks is recently introduced a fresh concept, right? Whether you are going with a ML flow, whether you are going with a regular data engineering or a machine learning, based on this, Databricks is divided the runtimes. Okay, so how it is divided, regular computations and regular kind of things for medium level data engineering, high-end computations and high-end machines for high level data engineering. Of course, this high level data engineering is come under, I mean, come along with, not under, come along with genomics, right? Of course, ML. If you are going to do anything for machine learning related or artificial intelligence related or a neural network related or if you want to build any kind of cluster for artificial intelligence or something else, that will come under ML. So this ML flows, some clusters or some groups might come with GPU, some clusters will never come with GPU. What is the difference between with GPU, without GPU, right? So these clusters, of course, these ML flows are also capable enough to process the genomics because these are the high-end machines, high-end cluster types, right? So that's why these are capable enough for genomics. That's why genomics is deprecated and the capabilities are distributed into both, right? So now the thing is two types, with GPU, without GPU. What is the purpose of GPU here? Last time, as I explained to you, the GPU is nothing but general purpose processing unit or general processing unit or graphic processing unit, might be different in terms of hardware, right? So what is the use of this and what is a work for? I mean, what are the different works it can do? It doesn't do anything much more, just like a processor, right? So it can do a specific task. Instead of processor do this all, it can take over and it can process. Mean to say, um, just take an example of a graphic card. Why graphics are faster than the regular processor when you are using graphic card in your machine, right? Because there is a specific GPU in your machine that is specific to process additional computation. Instead of execute everything in the CPU, take the tasks from CPU and execute them in more faster way, right? CPU has a limited capacity because it has to do all the things. It had to control the hardware, it had to control the operating system, it had to control all instructions, it had to control all input and output devices. It had to maintain the cache. It had to maintain the what it is frequency, and it had to maintain the everything, not one, everything. So in terms of that, CPU might be slower than GPU, because GPU specifically to execute a certain task, right? So what is that certain task? Whatever that arithmetic and logical operations which are happening inside the CPU, whenever a GPU detected, CPU, instead of executing them in a CPU will establish a bridge between the GPU and CPU. So what it will do, whenever it requires to execute some arithmetic or logical operations, it will never execute in CPU. It will just create a task and hand over to the GPU. Okay, specifically GPU will come up with additional processing capacity and additional cache and cluster clock speed capacity. Due to this reason, GPU has a more capable enough to process them in a faster way, right? Just take it as an example. To process 1 GB file in your regular processor, it will take, of course, it is not accurate based on the hardware. It might be vary. Of course, let's take. It will take 1 minute. Just imagine it. It will take a minute to process 1 million records or a 1 GB file in your regular processor. So let's imagine this: if a GPU is added to your cluster or a machine, at the time, if you try to process the data with the help of GPU libraries, GPU process libraries, right? At the time, that 1 GB file will be processed like a Spark, right? Within a second. That's the beauty of this CPU. That's why majority of the people will go with GPU whenever they are into the ML, right? So if the clusters are less and if the computation is less, then it is not required to go with GPU, because it's additional additional cost bearing again. All right. So the next one, this is the one which we just kept aside for today. And the next one, today's concept. So today we are going to create a new notebook and we are going to work with that notebook, right? So before going into that notebook, we have to know one thing. So we are aware of creating clusters and creating the runtime environment and everything, right? So here are the some what it is, some settings and some information of the executed or created cluster. Okay, these are the basic configurations, and here is the Spark environment, and here are the some JDBC or ODBC runtime environments, which can help you to communicate between uh, Databricks environment and outside environment. Permissions are not available here because it is in community edition right now. I have only the user who can create this, who can use this. And notebooks, how many notebooks are attached to this runtime? You can see all them here. And libraries, will come back into the libraries, and event logs. So whatever the logs were, whatever the events were performed on this Databricks, those events will be logged here, right? And Spark UI, you can see that the Spark information in a detailed manner here, right? So the timeline and graphic manner and how, I mean, everything in a graphics manner, how the performance is going, and what is the storage and its information, everything you can see here. Stages, storages, environments, right? So environmental information and everything you can see here. Executors, and you can see it is just fetching everything, right? You can see the information about the executors. SQL information, right? There are no SQL things as of now because no notebook is connected to this one. And JDBC, ODBC is a bridge between our, what I can say, our notebook, our Databricks environment and outside environment, and driver logs. So whatever the cluster drivers we are having, they will create some logs, right? There's a place for that where we can see the logs and everything. right? So here you can see the logs. Of course, these logs were created. These logs will be created into the data storage accounts or a container, right? And the metrics, you can get all the metrics here, right? Apps, whatever the apps which are running with this one, can go and check with that. RStudio is not connected and web terminal is not connected because this is not a licensed version. This is a community edition and it has limitations as well. Spark cluster information, right? Again, it will be same as the regular UI, right? But it's somewhat advanced. You can see deep level processings and deep level analytics of the UI here, right? This is the biggest thing. And whenever you are going into the libraries, why I kept this aside, libraries is a big concept, right? So whenever you are working with Databricks, sometimes you might need additional libraries to support your work or to support to make your process easy or to support some other environment or to integrate some other environment into the notebooks or your cluster environment. Okay, at the time, what you can do, you can come here into this cluster, whatever you are using to execute, I mean to say the computation engine. And inside that engine, you can go into the libraries and you can click on this install new to add that additional requirement, right? So that requirements or might be different types. Okay, so here simple upload. Let's go with this all first and then we can go with, right? Upload will ask you to upload that executable files or pluggable files directly into the Databricks library environment, right? uh, DBFS or S3. It is showing S3 because community edition is running on Azure, not into the, sorry, community edition is running on AWS, not into the Azure. That's why S3 is showing here. If it is into the Azure, it can show some kind of storage here. Okay, Azure storage or Azure container or something else it can show here, right? And PyPy, right? PyPy, we know that this is nothing but a package manager for Python, right? Package installer for Python. Whatever we are doing with pip install, the same thing will do it with PyPy. Okay, whatever the supported package you need, you can add it here. So here you can see some of the packages which you can see in the behind, right? NumPy, Pandas, Matplotlib, SciPy, Cbon, right? So these all are added from this package line, right? And Maven packages, if you are going with Java, so at the time Maven is required to you to add some more packages to you. That's why it is here. So Karen packages, these are required to add additional functionality for Scala and workspace. So these workspaces are required to what it is. If you already uploaded some kind of packages into your DBFS, you can directly pick the item, already uploaded item or shared by someone, right? So you can get packages from someone by sharing into the shared, right? You can directly select the package and click on install. Okay, this is about the installation thing. So majority of the things are having these sub-level tabs here. You can see, right? Majority of the things, not these all, but first three are having these three. First two, most probably, yes. So what are these? So whenever you are uploading, if you have ready-made with your machine, ready-made executables in your machine, instead of downloading from the website, what these things will do, these can pick the files, download the files from the internet into the Databricks environment and then install. Instead of that, if you have already downloaded a copy in your machine, what you can do, you can simply upload that executable file or drag and drop your executable file here and click install on this. That's it. So it might be jar for Java support. It might be Python EGG executables. That might be a package. That might be a something else. And there might be a WHL file for Python. So these are the two different things. So executables might be your own executable packages. Whales are different from, it might be combination of different languages. So I can say NumPy, right? Today we are going to take care of the NumPy, right? So NumPy is a combination of two languages, partially written in Python, and major libraries are written in C and C++. So once they are ready with it all together, they can build that as a WHEL file, WHL, we call it as wheel, right? This wheel file, and then we can install that wheel file. We can use that simply as a native Python package, right? That is the difference between executable and WHEL, right? These are the different things we can use here, right? I have installed these are the requirement things for me, and I have installed these all for my environment, and I can use them as I need it, right? So this is about the libraries, what we missed yesterday. So now I'm going to create a new notebook. So we all aware of that, how to create a new notebook. And I think so we have already created notebooks here. My notebook, I can go with this, right? So I have already created this old, what it is, computation engine is detached. I have to attach the computation engine. Until unless this notebook will never execute the code and no more useful. It's just like a notepad now. Okay, so what I have to do, I have to click here and I have to select the executable, mean to say the cluster or compute engine, right? So I believe we all are aware of this one because I have explained this earlier, but just go with brief. These are the basic things what we can perform as a file menu in Databricks for a notebook. Right, new notebook, you can create new notebook or clone, rename or existed notebook, move this notebook from one place to another place, delete, you can, I mean, you can perform the delete operation, you can remove your notebook, and upload data. What is this upload data? So this is nothing but it can do the same whatever we can see in the data. So it can take you into the DBFS upload screen, and it will ask you to upload files and things. You can see the same here. Haven't go with my notebook. I can open here because I haven't touched this. I can go directly. So when I click upload data, you can see this, right? This is nothing but upload data. Let's go with export. If you want to export your notebook into the separate kind, you can go with. So DBC archive means compressed archive, and source file is nothing but regular Python file. IPython notebook is nothing but notebook format where that different kind of web IDEs can accept, just like Databricks and Jupyter, right? These kind of things will go with IPython. IPython is nothing but Iron Python, which is web interface support format, right? And you can download this notebook and you can export between multiple users. I can download here what it is. I can download that IPython notebook here, and I can, if I want to load, I can simply load this IPython notebook into my data store or somewhere else, and I can take that directly into what it is. I can directly open that notebook from my data storage, I mean to say DB storage, right? That is advantage with this one. And publish, you can share your what it is, your notebook with a public URL. With a simple URL, you can share it. Anyone can open this notebook by clicking on the link. Okay, revision history clearing and change the default language. These two are nothing but, one is with history, whatever the operations you are doing here, everything will be stored into the revision history. And if you want to clear it, you can go and clear them, right? Or you can remove the specific history from here. All right. So by clicking on exit, I can come out from the history. And default language, as I said yesterday, you can change the language. If you change the language, that can be go with any of the thing, right? Here it is, the programming language is Python. If I can proceed with Python, I can go with. If I want to change back to Scala or SQL or R, I can use anything. If I select SQL here, you can see this was changed into SQL, right? Now, here the code is Python, right? So Databricks has enough intelligence that can add Python for the Python code, right? So as I changed it, I can go and change back to Python. You can see it is changed, but this Python is not changed because whether you are keeping this Python or not, it doesn't matter. It is optional, right? It will allow whether you are keeping the Python here with the percentage or not. It will allow because the main notebook language is Python. So that's why it is not removing it. If you want, you can keep, or if you don't want, you can remove it, right? That is about file and edit. You can do all kind of edit operations here as regular notebook. So cut, copy, but here a bit difference is complete cell related, right? You can cut the complete cell, copy the complete cell, or select all the cells or format the code, find and replace everything in cells. Okay, so set Python indentation mean to say whenever you are running a Python code, it is required to keep the similar indentation for all Python instructions. Okay, it should not allow you to start one from here it is two spaces, right? Just keep it in mind. Here I can go with print, and if I want to write another print with one space or two spaces, it will never allow. Means it is not, Python is, I mean, this is not a function. There's a simple statement whatever we are going to write here along with, right? These two are the simple statements, so you have to keep these two statements in a same indentation. If you're creating a function or a block of instructions, at the time you have to maintain the indentation for sub-level instructions of the main block or a function or a loop or whatever it is, it doesn't matter, right? That's a thing. So that indentation space you can select here. Here by default it is two spaces. If you want, you can go with four spaces, or if you want, you can go with uh, your way. But two is suggested because no need of wasting the space. And the view, how it will help you, it will not much help, but the way you can change the interface and the appearance, you can see it. It is only for you, not for the complete group. It doesn't matter. And you can see the standard and results only, right? You can see side by side, right? That simple view, standard in the sense cell in the top and result in the bottom, right? um, so you can see that the line numbers here, right? If you want to hide them, you can. If you want to keep them, you can, right? So command numbers, you can see that here it is not, I mean, it is not showing any command number because I just stopped it, right? By enabling this, you can see. So this is nothing but just changing the view appearance on your complete interface, right? So there's the one. So here collapse headings. So here you cannot see anything. These are the headings pad, but you are not seeing anything here, right? Because here it is collapse headings, because all headings are collapsed now. Sorry, we don't have any headings here to see. So to keep heading and keep complete content under that, we'll come back. We can see that later. We can see how it is and we can do everything, right? This is about all the stuff, right? If you want to create a new dashboard, you can go and create a new dashboard here. Permissions, as I said, it is disabled here because it is a community edition. Run all will help you to whatever, how many cells you have in this notebook, it doesn't matter. By clicking on this run all, it can go ahead. It can run all the cells from top to bottom, right? Clear. So it can clear the notebook. It can make some more beautify and some more readable, right? Results in the sense, whatever the results you have next to the cells. State in the sense, which is nothing but hidden memory for this specific notebook. Mean to say, if you are creating a variable here in this cell, that variable should be available in the next cell whenever you are going to add a fresh cell to that. That is nothing but a state, right? That is a shared memory. That is nothing but a state memory, right? So if you want to clear that, you can go with this one, state and result, and both whatever you want. Okay, clean state and run out. That means you can clear everything which is already cached, and if you want to reinitiate the complete process, you can go with this one, right? That's it, nothing much. So these all are the shortcuts, and here the biggest thing here is experiment and the comments. So whenever something come to you to review, or if you want to comment something, you can take this comment here and add for the specific cell, right? You can add your comment. Right, here it is. By clicking on this, the comment will add, right? So this is about comments and experiment. Let me stop these comments here and going with the experiment. So experiments are nothing but whatever you are doing here, if you want to keep them as a guide or something else, you can list them all here, right? Based on these experiments, they can others can come to know why you are writing this shorthand here instead of writing complete way, right? So that's the biggest thing, right? Revisions are nothing but whatever the changes we are doing here. By clicking on this, you can see, right? So if I hit save now, the whole thing will gone, right? Let me take it. So I'm going to take this, and I'm going to add one more cell. I'm going to paste it here. So now the revision history is here you can see two things. Here, this is a recent one where I have removed this line and added this line in the new cell. But here it is a old version, right? Wherever I have the two things in same. So if I want to restore back, I can click on this confirm. My current notebook is completely restored back to the previous. So this is what the use of history. And we had to be aware of this one. History will not be will not be available for long period, right? We had to be aware of that one. So this is what we can do here, right? So let's jump into the Python, sorry, NumPy, numerical package for Python. We can see all the stuff there. So that's the biggest one here. Let's start. So once we are ready with the packages which are installed in the engine, those packages are available in your machine, right? I'm going to get the headings now. So I'm going to add percentage MD. So MD is nothing but Markdown. This is the way how we can add the notes and headings to our notebook, right? So NumPy. All right, just going to take this. So shift enter. So this is executed and came down into the next level. So now you can see that, sorry, I just added this as a regular text. We have to keep hash here. By keeping this means it is a heading, right? This is a first level heading. If you keep two hashes, that means it is a second level heading. Let me show you that as well. So I'm keeping this NumPy, right? How to import this NumPy? I'm going to add one more cell with percentage MD. Come on, percentage MD. So subheading, I'm just going to create with importing, right? So you can see all the stuff here along with the what I can say along with the um, expand and collapses, right? I can collapse all the cells under this heading up to the next heading, right? I can collapse all the sub cells under this next level heading, right? This is how we can create the headings here in this notebook, right? Importing. Now I can go with importing part. How to import it? How to import a package into this Python, right? We can simply go with the simple import. Import numpy as np. All right. So by hitting enter, it can run, right? By hitting control enter, it can run. By hitting shift enter, it can run the cell and focus into the next cell. Let me clean this here. So numpy is ready. Now what we can do here? What is the use of numpy? So numpy is completely focused on arrays functionality, which can be added functionality to the Python. It can be faster enough than regular data type, regular extendable data types in Python, just like lists. But of course, numpy is going to play with the lists, but it is faster enough than the list, regular lists, because uh, Python Python will keep all the data in a distributed manner, but NumPy will keep all the data in segregated slots in a sequential manner. Okay, if you are storing 10 items in an array, what Python will do with lists, wherever the gaps in the uh, memory, it will go and sit in the gaps because it is having its own garbage clearance, right? But whenever you are using NumPy, it will never go to fill the blocks in middle, right? It will take a complete slot for the 10 items and then store everything in the simple series manner, right? That's why it is a bit faster enough. Definitely, these will be 2 interview questions. Why to use NumPy, and what are the different types of uh, runtimes in Databricks, right? So if they want you to test your proficiency and your in-depth knowledge, they'll definitely ask you the question, right? Now, so what we can do, how it can help us, right? So as I'm going to create arr1 equal to numpy.array, I'm going to create an array of 5. I'm going to create this. All right, of course, I can take it. 6, 7, 8, 9, and 10. I have taken 10 digits here. So once it is ready, I can use this arr1 to print. So no need to write print here because it's a notebook. It can execute and get the output as it requires, right? I just use this one as no attribute array. So I have to give the complete name. By mistake, I have given it because we have some wrappers where I can uh, where we can use the short names for instead of full names, right? So now you can see arr1 is an array of the 10 items. So if you want to see the dimensions or data types, you can. So I will explain you the dimensions and data types, how to go and how to make it more faster, right? So array1 dot d type mean to say data type. Let's enter this. Might be typo. Definitely it is typo, right? Here you can see this int 64, right? Int 64 in the sense 64 bits formatted int means long int, right? So if I want to change this int 64, I can change the data type here. comma, d type equal to int32. You can see it. The data type is changed into int32, right? So this is how we can go with. All right, let me take it into the next thing so that it can be very easy to you to read. Right, percentage, no, percentage MD hash. What is this? There's a creating array. Right. So I can simply copy this, edit, copy current cell, and I can paste it here. So instead of creating array, data type of array. All right, I can paste one more cell here. So now we have seen the data type and we can check the dimensions. I'll explain you step by step. Dimensions. So what are these dimensions? How these dimensions were useful in our thing? So what is the problem here? You can create a list with deeper, right? But whenever you are getting them back or whenever you are trying to perform some kind of things, it might be some problematic thing for you. But NumPy will provide different kind of functionalities where you can make the actions more accurate and more faster. Right. So let's check the existed array dimension with n dimension. So let's try, because this is a one-dimensional array, right? So if I want to go with the same array with there's an endim, right? So let me create array2 with either this one or another one. So let me take it 64-bit int, or the data types we can go with the simple thing, that is I for integer, right? S for string. I'll provide you all the stuffs, data type of array, right? I'll provide you all the list of things here so that you can easily identify what are the different data types. Right, here are the list of things. Where are these? Let me take it as a control C. Let me take multiple cursors. So use control to add multiple cursors in your cell. All right. So these are the different types of data types what we can use, right? I for integer, this integer might be different types again. B for Boolean, U for unsigned integer, means to say it is a universal code for integer, and float, and whatever the complex float you are having, mean to say long tail, and time delta and date and time delta, along with object, along with string, along with Unicode string, mean to say uh, special characters which are containing special characters which are not recognized as a regular language, right? We can use any of this string format here to go with, right? So I'm removing this as of now because we are going to check the dimensions here. So here I had to give the n dimension equal to 2, right? So here I'm giving a simple array, and how come it become as a 2-dimensional? Let's see. ARR2, right? Let's see it. Why ndim is not taking this one? Should come ndim. Why ndim is not getting into this one? What is the reason? Ndim should come. There might be a problem with dimensions. What is that dimension issue here? What is that dimension issue? What is that dimension issue? Might be typo. Probably that might be typo. Let me add n. Even though it is not coming, the reason it should not say this. It should say ndim. Why it is not going with? This might be again what it is, typo. My bad. It is not DIMN. It is DMIN. It's my bad. Yeah. Now you can see it. See, it is added two square brackets here. In the sense, data is trying to place in a rows and columns manner, right? Just like a matrix, right? Of course, it should show. I don't know the reason why it is not showing. Dot show. Let me try with this show what it can do. Obviously, it cannot work. Either I can use print or I can go with this one. So print is a regular Python execution. Yeah, simply it is. Right. So this is how we can create a multi-dimensional, simple way to create the multi-dimensional. Of course, it is not a accurate way. If you want to create your own multi-dimensional format, you had to go with a different way of structure, right? I'm going to take it as a 3, and I'm just going to create 3 by 3 matrix. 3 by 3 matrix. Now the data is floated into X and Y, right? Now the data is floated into X and Y. You can see all the information as floated in X and Y's, right? It is a 3 by 3 matrix now. By printing it, you can see I can remove this n dimension and I can go with array 3. By running it, you can see all. So it is a 3 by 3 matrix now, right? By seeing this n dimension, you can get that the depth. If you want to add one, some more depth, right? If you want to add some more depth, you can add. So it is floated into the XYZ thought dimension. Right now you can see the 3 dimension. If you want to go with some more deep, it will never restrict you to stop with some level of dimension. It will allow you to go uh, with the extreme level, whatever you need to place, right? It will take you into the extreme level. It doesn't matter up to what level you can go with, right? So by running this, you can see it is into 4th dimension now, right? What are the different dimensions we have in a graph? Anybody? I know you guys are more familiar than me. about graphs. So what are the two dimensions which we are aware of? X and Y, right? So along with this, we have one more, that is Z, which is ready to plot in the third dimension in terms of depth. So the negative dimensions for this are also known as -3, also known as 6 dimensions, minus directions. Hope you guys familiar with this. These are minus directions, right? These are the 6 dimensions, right? Whenever we are trying to plot more accurate three-dimensional data, three-dimensional graphs or something else, we are going to plot in a XYZ. If you are going to plot some more deep data, that should be into the negative directions of the first 3. There might be some more else. Of course, we are not going into the 11th dimension again. We'll just stop here. 3 dimensions with inverse, right? So let's clear all drawings here. So these are the 4 dimensions. So till here, just a way how to create array with the different dimensions and different ways, right? So now how to slice values, how to get a specific values from specific things. Let me close the drawer. Yeah. So how to pick the values, right? Percentage MD. Get values, right? So now I have to create something just like how to get it. You can get it simply as a regular array, right? You can get, sorry, uh, array1 of 0th element. All right. So by running this, you can see it is picking 1. So if I pick the 9th element, what it will do? It will say 10 because n minus 1. Okay. So just like this, we can. So also we can go with the range. Okay. I'm going to pick 3 from 7. What it will do? It will get all the information, whatever we require, right? It starts from 3rd index to the 6th index, right? So that's how it is going with. And sometimes someone will ask you to get the what it is, steppers or something else. What does it mean? What is its second parameter? We all know that simply, as I can say, if we kept the same thing, just like, where is this command? Just like colon minus 1, we all know that it can reverse the values, right? But what are these? What are these 2 things, and what is this actually, right? So the first thing will start index, and second thing will be the end index, right? Upper boundary, lower boundary, and upper boundary. And the third item is nothing but stepper and order. Okay, if you give it as a -1, it can come up with from the reverse order. Let's see by giving individually, right? We can add this. Let's add print for each of this. All right, we can simply use this as a simple list. Of course, here I'm just making you as familiar with what it is, Numpy. There are advanced concepts with Numpy, mathematical operations, slicings, restructuring data. There are multiple things because this Numpy is useful in upcoming packages. Okay, it might be reaching our deadline. Okay. Just like tomorrow onwards, I'm going to take some more faster, right? So now I'm going to take it as a this one. Just let me create as you want. So whenever I'm taking one, the step is one. That means everything will be come with single steps. Sorry. Okay, so now I'm using Control Enter here. You can see the regular array here, right? For the next one, if I'm going to give two, what it will what will happen here? Anyone guess it? What will happen? It can pick the every alternate value. Let's see it. You're just getting all odd numbers now, right? If I give 3, the step, every third item, right? That's how you can go with, right? How many you can skip, you can go with. So if I add the stepper here, it can go within the range only. So I'm giving -2 here. Let's see what will happen. So -2 will not take anything because -2 is not an step, but -1 will help you to take in a reverse order. That's it. It will never go with anything, even though here it is not going in the reverse. Of course, let me try. Yeah, it is getting in a reverse order, right? It should go with the range. I don't know the reason why it is not. Let's try with -2. Obviously, it is going in a reverse direction, but I don't know the reason why it is not going with this one. It had to go. It had to go. Let me try from -3 to -7. Let me try with this. Yeah, it is going, right? So it's going, and in the same direction it is picking that each alternative, right? This is how we can get it, right? This is nothing but a step uh, steps. While whenever you are trying to slice the values, it is a step ways to get it. Okay, now we know how to get a values from individual array, but how to get from n dimension array? There is a 0th dimension. Let me explain you the dimensions here, where it is. Yeah, here it is. So let me explain you the dimensions here. Okay, dimension 0, d0 equal to just a value, just a value. That's it. It's nothing but np dot array, just a value 10. That's a one dimension, right? Let me duplicate this. I'm taking it into the 4th level, not going with beyond, because of course we can go, but I'm not going. Let me take till 3. So one dimension, 2 dimension, 3 dimensional, right? So whenever it is in a 1 dimension, this should be in a list. Come on, it should be in a list, right? And of course, we are not supposed to create different types of strings here, different types of data types. If you are going to create a string type data, you have to keep all items in a string form. That's a standard structure for array. Whatever the data you are keeping, that should be same in all, right? 8, 6. All right, I'm taking this into the 2 dimensional now. So array with rows and columns, 2 rows with 3 columns, right? 3 dimensions or nothing but a dimension with the repeated second dimension, the depth value. All right, just like this. So if you want to check the dimensions now, you can get, so there are multiple things, right? D0 dot, what is a type to get the dimension? Ndim. And this is a function, this is a property to get the dimension here. 1, 2, 3, and you can go with 1, can go with 2, can go with 3. But here is a problem. This D is capital here. All right, let me run this. See, the first one is 0th dimension. Second one is 1th dimension, right? Just like this. These are the dimensions of the array. So now we have these all. How to get this, get the values from these dimensions? So let's use, we know how to get it, right? From the 0th dimension and 1th dimension. From the second dimension, how to get the value, right? So whenever you are trying to get the value from the second dimension, so that's simply as you have seen it, just like this. So simple way. So which dimension you want to get it? We are using second dimension, right? I'm going to get the value from the first row, right? First row is nothing but 0. And I want to get the second index. I mean to say 2 is nothing but third index. I'm sorry, third index. Let's run it. Of course, it will show the error. I know, but it is returning 6. So this is a wrong format, right? Why? Even though it is running, why? Whenever we are trying to pick the values, pick the data from an array in the range, we have to give in this format with a colon. But here I'm giving it as a comma. Why it is working? Because we are applying this structure on two-dimensional array on NumPy data. That's why it is more familiar and more useful. So if you want to get in a different range, 2 to 4, I don't know whether the index is available or not, right? Just like this. So 1, 2, 3. You can see it now, right? We are getting 8 and 3. Are these available, 8 and 3? So it is saying, sorry, 8 and 6, sorry. So are these available? Yes, 8 and 6 are available here, right? So this is how we can pick it. If you are using third dimension, so what you can do, you can go with 0, comma 1 or 2, whatever the next thing. So this is for X dimension, this is for Y dimension, this is for Z dimension, right? You can go and pick whatever the value you want. So somehow it is saying 2 decimal, but 3 were indexed. Oh, sorry, it's a 2-dimensional, but I have given 3. So I have to give the D3 here. See, it is picking the value. So this is how we can get the values from n-dimensional structure, right? It will never restrict you to go with the simple linear array or linear thing. It will allow you to go with the complex arrays to handle with the data, because real-time work is not as simple as standard Python gives, right? We need some extended types that comes from NumPy, right? This is about simple arrays, creating arrays, getting arrays, and doing something with this one. Of course, there are multiple things. We'll see these things tomorrow. How to reshape the existed things, and how to search, sort, filter, or we can loop through, right? We can see these all simply, not with the maximum one. And also there are some standard mathematical operations to do. Of course, I can show it now only because it is a very small thing. Whenever you have some array, you're not supposed to, with a simple list, you cannot do some kind of add, right? x equal to simple 1, 2, 3, 1 comma 2 comma 3, right? So if you have this one, what will happen? X plus 1. What will happen if you run this? It is an error, right? So, but NumPy will allow you to do such kind of operations. Of course, there are multiple, but let me explain you the small thing here. D1 plus 2. The data type. Okay, these are strings. Let me take array 1, A or R2. See it now? So it is going to add all twos to this one. Print array 2. Let's see. So here it is, simple like 1, 2, 3, 4, and all the numbers are incremented with 2. This is an additional advantage. You can simply update them, add the mathematical operations to all the items into the n level, to say n depth. Okay, we can see some more in the upcoming videos. Tomorrow, we're going to finish this NumPy with all its extended features. Right. So had to do more practice and you had to get familiar with this because they'll definitely ask you some questions on NumPy whenever you are showing more than 2 years experience, or at least more than 1 year experience. You have to familiar with this NumPy. All right, guys. If you have any doubts, just ask me now. Okay, then I'll take it as no, and we can wrap this call. Thank you, guys. Good luck.